Good afternoon. Yeah, I work at Project A. Project A is a Berlin-based venture capital firm that invests in digital business models. And so different than other venture capital firms, we not only give our founders money, but we also help them operationally. That means we have a team of 100 experts that help the companies with growing their online marketing teams, IT, HR, business intelligence, and so on. I work in a team that tries to help our companies more data-driven, and that means a lot of things from ad hoc analysis to machine learning. But what we do a lot is data engineering, and I will talk to you today about data engineering. So who in the room would consider himself here a data engineer? Not so many. And who would say he or she is a software engineer? Some more. And who would say he or she is a data scientist? Okay, it's quite a minority. Let me show you how data engineering looks like once we have the first slide. Yes. So that's my talk. I will talk about pain reduction in data engineering. Okay. Yes. Do we have a remote control? Okay. So this is how it looks like. Here's a team of 2 data engineering. To see the left one down there, the second one, fixing a data pipeline. And my point is, I would say if you look at the industry, if you look at the ventures that we're seeing, if you look at candidates, this is data engineering. So it's quite painful. So people are faced with scripts run failing all the time in really annoying ways. People are faced with stuff that they cannot debug, so they see some Java stack trace and have no idea why that's happening. They are faced with really long runtimes of stuff, so if they want to build something, they change something and they maybe have to wait a day until they see whether the stuff they were doing is working. So they end up doing lots of stuff in parallel, working on different things because they have to wait for stuff. Then there's the bad tendency of people coming into a room and say, can you quickly help me with something else? I need a quick query here and there. And also, in general, you have the problem that very often things that you build is kind of already kind of not needed anymore at the point when it's finished because business changes their mind very often. There's also lots of other things that are painful there, but I will talk today a bit how to prevent that, because in the end all we want is kind of sanity and a peace of mind. And I think you can get there by applying sanity and standard software engineering practices. And this is a bit what we do. So people who kind of want to start making their company data-driven, they often think that they can solve this problem by picking a technology, right? So it really saw that happening, so that people were hired and tasked to build the data lake in hope that that would kind of solve the problems of the company. Well, and that doesn't solve it, right? So, or that people, what's even worse is the CFO talks to consultants and then they talk to salespeople of the big BI vendors. And in the end, an arbitrary decision is made based on some feature metrics to select one of those enterprise BI tools, and then some poor guys have to implement that. That usually does not help, and our recommendation is to not pick technologies at all, but first hire people that, and then tell them what your business problems are, and let them figure them out themselves, what technologies they want to use for solving that problem. Right, so the technology you use for data engineering and data science in general should fit the company culture and the skill set of your engineers. There's a bit of a danger with that because young engineers often want to do fancy new technology stuff. And so there is a bit of a risk that people use kind of real-time big data technologies that were built for use cases that Facebook or Airbnb and so on have. Right, so where you have really kind of real-time requirements or like petabytes of data. Most companies, at least in the world that we see, don't have these use cases, and especially not in the beginning. But then still, I was seeing like Redshift clusters with a 5 GB data warehouse, or Spark only ETLs for, well, a few 100 million rows of transactional data, or Hadoop jobs that do trivial stuff and then fail all the time. So there is a bit of, I would also encourage you to resist the urge of using fancy new technology that with all the additional complexity, and will focus on simple things. So the main point I want to make is that when you do stuff, make changing things and testing things easy. So that will kind of take the whole pain out of data engineering. And so many people, when they do data engineering, so like getting data from different data sources of the company into something that can be queried with, for analysis, but also that can serve as, well, the basis for things like product recommendation, CRM automation, and so on. What many people do is they use these kind of click tools. So this morning we have seen Talent and so on. So I don't think that's very good and very scalable, because these things are usually very hard to debug. So it's kind of, when something breaks, then, well, you're really in trouble. Was looking through Java stack traces. They are hard to change, because when you click stuff, usually these tools are not so good for working in parallel. So there's nothing you can put in a Git repository and then apply in a software engineering. Yeah, and right, so it's kind of hard if you have a kind of 10-person BI team or data engineering team that wants to solve stuff. I think what the whole industry is moving to is to have data pipelines as code, right? So I think that's a trend that we have seen in the recent years. So everybody is kind of following on that bandwagon, and that means usually in a kind of not petabyte data warehouse case, that means just SQL scripts, Python files, and well, some shell scripts. And then also what it means is that the structure of all the tables and all the metadata, but also the content of your data warehouse well, is then the result of running code. And that has really nice properties because code is something that we know how to look at. We just read it, it's text, but it's also usually easier to debug. And well, and also if you do that, so if you kind of apply this normal, I would say, software engineering process, then, well, then you can develop stuff on your local machine. Once it works somehow, you kind of run it on a staging environment on the whole range of data, and once that works, you put it into production, right? So I think that's totally normal in software engineering, and starts becoming a kind of best practice in data engineering. Well, and if you start building a data warehouse, or you start integrating data to do analysis or something else, my recommendation is always to start with scripts. Really kind of just shell commands that do stuff. For example, here you have something that unzips a file, kind of runs pipes the result through some Python script, and then pipes the result of that one into a Postgres database. This is also how we run pipelines. Or where you just cut a SQL file that does something and pipe that into a database. So we usually use Postgres for various reasons for that. Once you are there, then you also discover that SQL is actually a really nice language for doing data processing. And that can be as simple as just creating a table that, for example, here it's a dimension for a region. Right, so just a table that is the target of your computation, then doing some transformation of previous data that you already kind of gathered or processed in a previous step, and then insert that into that table. And afterwards, well, maybe also insert some unknown values, and afterwards add indexes to that table so that it can be used for subsequent transformations. And well, and so this is how what I recommend everybody to do. So right, to do very simple things, leave data in a database, run queries there, and well, build your pipelines step by step by running simple scripts. Once you reach a certain complexity, then you need to kind of invest in an ETL tool or do something where you basically can run stuff in parallel, or where you also formulate dependencies between these different processing steps that you have. And well, and you also maybe want to have a bit transparency of what's going on, and so that people can see what's happening. My recommendation is to, well, also build this on your own. It's very easy. Or use, I think the industry standard has become Airflow from Apache, which is from Airbnb. It's an Apache project now. There, basically, you also describe data integration pipelines as a kind of network of dependencies of jobs that have to run after each other. We also have something like that, which we call Mara, which is our own ETL framework. But actually, orchestrating this stuff is not the important part. It's more like this mindset of, well, having data integration as code and somehow running it in parallel. So I think applying proper software engineering is kind of, well, I think the key method of reducing pain. And then you can focus on the actual difficult stuff. And for me, integrating data of a company into something that is consistent and correct is the key challenge of doing the whole thing, right? So people who use your data, they won't trust it if they look at one part of the system and see one number, and another part they see something with the same name that's a totally different value. And they also won't trust it if they see obvious bugs and so on. And so I think you should really invest in consistency and correctness and ensuring that. And the easiest part is something that I call a referential consistency that is making sure that things kind of fit together. So for example, you have here a table that, maybe you cannot read it, but it's a table that's called city. It has two values, Berlin and Budapest. And you have another table that's called customers, which has an ID and an ID of a city. And so it's very easy when you do ETL to do something like in the left bottom, where you kind of insert customer 1 twice. So that could be the result of a kind of wrong join. Or where you kind of insert a customer 2 with a city that doesn't exist. Right? So that's very easy to do. Anyway, if you then run analytical queries like this one, like the number of customers per country, whatever the query is intended to do, it's kind of not meaningful on this kind of tables, right? So what I encourage you is to, well, check that the data, the assumptions you make in queries running on your data kind of are enforced in the data that you have. So for example, Postgres, you basically can add constraints where you say there's unique constraints and foreign key constraints and so on. Much more difficult is something I call computational consistency, where basically you try to avoid business logic. This is from a company that we worked on 3 years ago, that where in different parts of the data warehouse we had logic, what a processed order is, and so on the top you see something like the revenue is all orders that are pending, accepted, completed, or proposal for change. Then elsewhere in the ETL was something like, okay, this is a processed order if these conditions are met. And somewhere else I found something like, it's unprocessed when the last status is not pending. Right? And so if you end up with this kind of logic, then you are kind of screwed, and you will never get to something that is consistent. And well, again, this requires proper software engineering discipline. So you need to refactor this. You need to do something where you pull out that logic to an earlier processing step and make sure that you compute everything you know about an order only once. The whole thing gets a bit more complicated when you have things like here, where you have orders, and orders have a revenue, but then you also have customers, and customers have a lifetime revenue, and products have a revenue in the last 6 months. And also customers have maybe a favorite product and a first order, so you have kind of circular dependencies between these objects. Well, and then, well, you have to deal with that by introducing proper abstractions. I will skip this a bit. Also, when you do, well, having kind of checks on the data itself really helps. For example, if you have a check like this, where you say, okay, all the number of rows in this one table should be the same as in the fact table, that really helps finding bugs that you introduced when you change something. Or when you could do a transfer, for example, of the number of first orders from a order kind of table, and you have also number of attributed first orders on a touchpoint table, then you make sure that the sum of them is the same. Or if you process marketing data, then here you assume, or you kind of enforce that each AdWords campaign has a channel label, and so on. So this really will help you. The last one is semantic consistency. That's something that's really hard. So if people look into different dashboards and there's something called revenue or profit, then you want to be sure that profit, or in this case contribution margin 3A, is always computed in the same way, right? So people won't trust your system if in different dashboards has a different meaning. And here is the computation of contribution margin 3A at one of our companies, so it's a really complex term. And also it's guaranteed that this definition changes over time. And so you need something that when you change the meaning of your metrics, that also everywhere you look in the systems, these are applied in a unified way. And there are several ways to do that. We use something called Monogram for that. Also very good Looker ML. It's from a commercial product, or your own kind of schema. Yeah. So that's it. If you have to take something home from this, it would be the advice to apply kind of principles of simplicity and focus on the complexity of the data itself rather than the complexity of technology. Two last remarks. We are open sourcing our BI infrastructure. So parts of that are already online. We will also open source our ETL tool this year. Another thing, if you want to talk to us, we brought this very sofa here, including also this lovely team. So there are one floor down here. Talk to us. So we are all here. Last one, if you know somebody who wants to work in Berlin as an analyst or data engineer or data scientist, refer them to us. We pay €200 for each referral that gets hired. That's it. Thank you very much for your attention.